Our next video then is looking at how we can draw a non-linear curve and a linear function on the same graph, see how they intersect and cross to give us a few answers and useful bits of information. Here we've got a parabola curve created from the equation y equals x squared, or function of x is x squared. Remember, if you can't remember the graphs to do with parabolic curves, have a look at a couple of videos back where we discussed it and how to draw them and so on. I'm also plotting now another equation on here, this time a linear curve because the parabola is non-linear, where y is equal to x plus 5. We know that would be the case because x is going up by 1 for every one y, and it crosses the y-axis at 5. Again, if you can't remember how to write linear equations from a graph, make sure you have a look back at that so you understand what I just mentioned. Now what that tells us is that those points at which the lines cross, the answer is the same. Y will be the same value at those two equations will be equal to each other. So in other words, x plus 5 is equal to x squared. Let's just have a quick look at that. X is either 2.8 or minus 1.8 from this graph. So obviously 2.8 add 5 is 7.8, and 2.8 squared is 7.84, as this is just an approximation. And then minus 1.8 add 5 is 3.2, and minus 1.8 squared is 3.24. Again, an approximation, it's been rounded. So that shows how the x values of 2.8 and minus 1.8, y is identical in those two equations. So intersecting a linear and non-linear allows us to work out all the solutions for that for the equations that are identical between the two. And it doesn't have to be a parabolic curve, it can be any shaped curve. For instance, this curve by here I've done is x cubed plus 5x squared minus 6x plus 4 plus 8. I put my linear linear line through it, in this case y equals 2x plus 3, and we know that those 3 points, these two equations are identical. So in this case x is minus 4.25 or minus 1.5 or 3 roughly. What we can also say is that the second equation, or the equation with a higher number of powers, take away the first equation, will be 0. So for instance, if here I've got my second equation being x cubed plus 5x squared minus 6x plus 8, and I'm going to take away 2x plus 3. So when I put those into the equation, I get x cubed plus 5x squared minus 6x minus 2x, that's taking away the 2x from the first equation, plus 8 minus 3, taking away the 3 from the first equation. And I know that this equation here is then equal to 0. It can be handy because in the case of a cubic equation you won't have to work with it, but in case of a quadratic equation creating a parabolic curve, it might be useful if you've got a parabola or a quadratic equation is equal to a linear equation, because then when you move the linear equations, when you deduct it away, you'll end up with a quadratic equation being equal to 0, and you can solve it using one of the several techniques such as the formula or factorizing that we have used in the past.